We are solving question number 38 of GATE 2016 Chemical Engineering paper. The characteristics curves, that is head capacity relationship of a centrifugal pump, is represented by the equation delta H pump is equal to 43.8 minus of 0.19 Q, where delta H pump is the head developed by the pump and Q is the flow rate through the pump. This pump is to be used for pumping water through a horizontal pipeline. The frictional head loss delta H piping in meter is related to the water flow rate QL in meter cube per hour by the equation delta H piping is equal to 0.0135 QL square plus 0.045 QL. The flow rate in meter cube per hour rounded off to the first decimal places. The water pumped through the above pipeline is dash. So in this question, we have been given the head developed by the pump, that is delta H pump, by the equation 43.8 minus of 0.19 Q. And this pump is used for pumping water through horizontal pipeline. And the frictional head loss, that is delta H piping, is given as 0.0135 QL square plus 0.045 QL. The flow rate in meter cube per hour rounded up to first decimal place of the water pump through the pipeline is dash. And then we have been asked to find the flow rate, that is Q. Now from Bernoulli's theorem, we can see that in this given question, the pipe is flowing through the water is flowing through a horizontal pipeline. So we can simply equate both of this pressure, that is the pressure head developed by the pump and the frictional losses due to this piping. So that is, we can write this as delta H pump is equal to delta H piping, and basically the Q, that is the flow rate through the pump, will be the flow rate through the pipeline also, QL. So we can write this as 43.8 minus of 0.19 Q is equal to 0.0135 Q square plus 0.045 QL. We can equate this as 0.0135 Q square plus this will become 0.235 Q minus of 43.8 is equal to 0. So we can find the value of Q by solving this quadratic equation, and it will be, so first let us simplify it in terms of ax square plus bx plus c. So it will become Q square plus 17.407 Q minus of 3244.4 is equal to 0. So from that we can get the value of Q as minus of b plus or minus b square minus 4ac upon 2a. So we can replace all those values and we will be getting minus of 17.4 plus or minus 115.24 by 2. So the value of Q will be minus of 17.4 plus 115.24 by 2, or minus of 17.4 minus of 115.24 by 2. So this value will be negative. So this is not negative flow rate is not possible. So you can neglect this, and the final answer will be getting by solving this. So numerically, this will be, the flow rate will become 48.91. So the flow rate of the water pumped through the pipeline will be 48.91 meter cube per hour. So that is, we can write the final answer as 48.91.